Hey, what's up Node.js developers? Welcome back to a new live stream. Today I have prepared something special for you. Today we're gonna build and deploy a GraphQL API using only Node.js. The goal of this tutorial is going to help you learn GraphQL fundamentals, and the focus of it is going to be on the server. How do we build a GraphQL API ourselves? Because we have a lot of tutorial on this channel focused on the client side, where we are consuming a GraphQL API from React Native or React.js. If you are interested in that, you can check it out here. But today we're going to focus on the server. In our previous tutorials, the way we have implemented them was using GraphQL, was building a GraphQL API using IBM StepZen. This way, IBM StepZen allows us to easily create and build GraphQL APIs from different data sources. If you're not familiar with it, check out the other tutorials we have. It's really easy to build it and deploy it, and it's also very easy to scale. The way it works is, in the previous tutorials, we simply run a CLI command like stepzen import database. Then stepzen was doing the magic, and in return we got a fully functional GraphQL API. The thing is that the magic that is happening behind the scenes, when you know what's happening, like you can understand very well the benefits, or you can understand how to work with it. But if GraphQL is something new to you, I believe it's hard to understand, okay, what's happening there? How is everything so easily created? So to better understand that, we decided to create this tutorial where we will learn and build a do-it-yourself GraphQL API. For that, we're gonna only use Node.js. We're gonna use the GraphQL HTTP library. We're gonna use MongoDB to connect to a database to see how we can pull data from different sources. And at the end, we're gonna deploy this to Amazon EC2 to make our API publicly available. So I approached the guys from StepZen, and they loved the idea and they decided to sponsor it. So thank you very much for making this tutorial possible, and thank you for being together with us and making GraphQL more accessible to developers. If you're ready, let's get started and let's see what we're gonna do today. All right, so before our tutorials are very hands-on and practical, and I can't wait to get started with the coding, but I will cover like probably maximum 5 minutes of theory about GraphQL, what it is, and because I guess if you're on this tutorial, you most probably heard already about GraphQL, and I will try to explain you how to work with it and by building something with it. So let's start with just a little bit of theory. So here it is, GraphQL. What's the benefits of GraphQL? First of all, it allows us to first describe the shape of our data, describe how is our data looking. Then from a client side, we can ask for specifically what we want. So compare that with a REST API where we send a request for, let's say, posts, and the REST API will give us all the information about posts. With GraphQL, the benefit is that we can ask specifically for the fields that we want. And in result, we get predictable results with only the data that we requested. So compare GraphQL APIs with REST API. In REST API world, usually we have a separate endpoint for different models, for example, /player, /team, /matches, and we send a request there. The API gives us all the data that it knows about, for example, a player or a team, and then the worst case is when we need a lot of data for a specific screen. In that case, we would have to send multiple requests to a REST API just to get the data that we need. So with GraphQL, On the other hand, we can build these queries to get all the data that we need in one single query. So from a client side, we send one request with information like give me information about player, their teams and matches. GraphQL is going to go ahead and grab the information from where it's stored, will process it, and then will give it back to the client. So yeah, that's small, some of the benefits, like really short. We're gonna see today more of them, but what makes like the core concepts of a GraphQL API on the server side are the following. We have types, which we saw in the previous screenshot as our way of describing our data. We simply create the types, we say what fields it have and what is the type of that field. Very similar to how TypeScript is working, but don't confuse it with TypeScript. This is GraphQL type definition. Then here on the right, we have resolvers. Resolvers are simple functions that tell GraphQL how should I go get the data for this specific field. So in some cases, it's going to read from database layer. In some cases, it's going to go ahead and call another API, or we'll do some processing around it. But in general, like a resolver, the goal of a resolver is to go get the data for a specific field in our types. And then we return the response. So that's everything that I'm going to cover about the Fiori at this stage. Let's go ahead, get started, set up our GraphQL API, and a lot of things will make more sense as we go. So before we do that, let me say hello everyone who is joining us live. How are you doing, guys? Mohamed, Osama, Victor, Robert, Julio from Denver, Colorado. Hello, Julio. You already know that what I was about to ask. Where are you joining us from? Let's see the geography of our live stream. Come on, my keyboard, of course, disconnected. Let me go ahead and start by, I think sometimes I'm working in a terminal, but today I feel like just opening up Visual Studio Code and starting from here. Have a lot of things in Visual Studio Code. Let me go ahead and do close folder. Yes, just to start a blank new Visual Studio Code. You don't need any kind of fancy editors. You can do everything like even in terminal, but of course it's going to be easier if we have a visual editor. So what I'm going to do here is let's go ahead and do file. I just realized that I never created like a new project or a new folder from Visual Studio Code. And I'm not even sure that it's possible. We can open it. So I think that the first step is going to be to go ahead and create a new folder. And that's where either you will gonna use your files, or I'm going to open simply a terminal to do it a bit faster. I'm gonna go ahead in cd my projects. Let's do projects, YouTube, and let's do 0.2, 19. And in the, all we have to do is create a new empty folder in which we're gonna create our Node.js server. So let's go ahead and create with makedir the folder called GraphQL test. And let's open the newly created folder with Visual Studio Code. You don't have to do it like necessarily with terminal. An easier way would just be to open the files and create it that way. That's perfectly fine. And here, after we open that folder in Visual Studio Code, here we have it. We do not have any files yet in that folder. So that's why let's go ahead and open a terminal window in our Visual Studio Code from where we will start by initializing a new Node.js project. To do that, all we have to do is npm init to initialize the project. And we can even provide the -y to say yes to all the questions that it's gonna ask. So this process, what it happened is it created a package.json file. And the next step in the package.json is going to be to create our server file. So let's go ahead, create a new file in our project called server.js. In this server.js, if we simply do a console log hello, what we can do next is we can run and execute this server.js using Node and provide the server.js file. In the console, we should see the hello world. Okay, so if you're interested, my Node version at the recording of this video is 20. Hopefully you can see it well this way. Now I'm gonna go ahead and open up the GraphQL documentation. Let's write GraphQL.org. Is it going to be here? Yes, I think so. And we're gonna follow the documentation, but at the same time, take some detours. So if we go to GraphQL.org, let's go ahead and press Get Started. In the Code tab, let's go ahead and choose JavaScript here. From the different servers that we can build with, I'm going to choose the first one, the GraphQL.js, which is the most simple GraphQL library to build a GraphQL API. So let's follow this documentation. What we have to do is first we need to install the library called GraphQL. To do that, I'm going to run npm install GraphQL in our terminal. What this has done is in package.json, we should see the dependency of GraphQL here. Perfect. Now, if we look at the documentation, let's go ahead and write our code in the server.js file. We're going to first, let's go ahead and basically copy paste this code. And then I'm going to explain what it does, and we're going to play with it to see how we can adjust it. So from the documentation, let's go ahead and paste the code. And if we, for example, now we're going to do node server.js, what we should see back is a response, which is an object with data and then hello world string. That's the hello world, and let's have a look at what do we have here. In the hello world example, as I was telling you before, our GraphQL is created from two things. From type definition, and the type definition, we see them here, which means that we have a query, and the query has fields. Hello is the field of our query type, and it returns a string. This is only half of the equation. This is specifying what is the shape of our GraphQL API, what types or what data it returns. Then we have a root value, and this serves as the resolver. The resolver is specifying how should we go and get this data. It has the hello field in order to provide to specify how should we provide data for this hello. And what it does, it simply returns a string hello world. In more complex situation, that's where we're going to, for example, fetch data, for example, from database, then process, and then return the data. So that logic is going to happen in our resolvers here. And the last step here was us simply executing a GraphQL query. So we provided the schema that we created, we provided the root value, and we provided the source. Basically, what query do we want to run? Here we specify that we want to get the value hello. and then we simply logged it on the console. Now, in order for you to test, try yourself to go ahead and add another query that will return the age as an integer, and that age should be a hard-coded value of your age. Then try to execute this in the GraphQL query, and what the goal of this exercise is, when you would execute node server.js, you should see here age, and here, for example, 25. Try to do it yourself based on the example that you see here and think about what should we change. And after you have tried it, let's go ahead and try to do it together. So, again, whenever we are working with GraphQL, there are two sides of a coin. The first one is the type definition. We need to specify that, hey, there is a new query called age that will return, in this case, not a string, but an integer. This is another type that GraphQL supports by default. Now I'm going to skip adding in the root value here the resolver, and I'm going to go ahead and in the run the GraphQL query, I'm going to say, besides the hello, or instead of the hello, I want to get back the age. If I'm going to go ahead and execute this query, what do you think will be the result? Will it be an error, or will it have a value? Well, it's not going to be an error, but the value of the age is going to be null, because the age is defined in our type definition, but we didn't specify how should we resolve this value. How should we, where should we get it from? And that's why we see null. Now, if I'm gonna go in the root value object and add here after the hello another function called age, we can either hard code it with 25, and this will also work. Yes, age 25. Or we can provide a function that will do some calculation, or it will do some fetching, and then it will return the value 25. That's also possible, and it should be an arrow function here. So if I'm gonna do that, we see that it's also 25. So that's all it takes to build some endpoints. We specify it in our type definition, and then we provide a resolver on how we should get the data. So at the base of GraphQL APIs, everything is super simple and fundamental. Then when we start adding multiple stuff around it, validations, mutations, and so on, it might feel that it becomes more complex, but if you take it step by step, as we will do in this tutorial, everything will build up on top of each other, so it's going to be much easier. All right, so that was the hello world. But as you can imagine, should I or shouldn't I? I think I'm going to do all the tutorial in the same project, and for that reason, let me go ahead and do a git init to initialize git, so that later you're gonna be able to look through the commits to compare it with your code. And I'm going to do here a new file, git ignore, because I want to ignore at least the node modules. Now if I'm gonna go do git status, we see that we are about to commit, or about to add the git ignore, the package, and the server without node modules. That's important. Let me go ahead and do git add, git commit -m, hello world GraphQL. At this moment, it's not even an API. At this moment, our server is a script, because to interact with it, we simply execute it with Node.js. It runs everything, it gives us back the data, and then it stops. A server, on the other hand, will listen for incoming HTTP requests. Whenever it receives the request, it will send back the data. So let's go ahead and see how we can transform this GraphQL schema and serve it over HTTP as a server. To do that, we can continue checking the documentation, and let's see the next page of running an Express GraphQL server. Express is a package that allows us to run HTTP APIs in Node.js. So let's go ahead and install the following libraries. The libraries that we're going to need next are, let's do npm, or let's do clear first. The libraries are npm install Express, because the Express is the library that will allow us to create this server that will listen to incoming requests, and the GraphQL HTTP, which is a tool to create a GraphQL API. Very simple library, very minimal. Not sure if it's used in production a lot, but for the learning purpose, it will do its job. Later on, we're going to see and we're going to start using different libraries for our GraphQL server. But for now, just to learn and to understand the fundamentals, this should be more than enough. So if we look in the package.json, besides the GraphQL, we have Express and GraphQL HTTP. Let's go ahead in our server and let's start by importing Express but equal require Express. A bit later, I'm going to transform this project to a module in order to use import from, because I don't like the require way of importing, but for now, let's keep it simple. And what I want to do, what I also want to import is, I want to import something from the GraphQL HTTP. And what I want to import is the create handler. It's a way to provide a schema and to create a handler that later we can assign to Express. Okay, let's go ahead. The last query that we are running here using pure GraphQL, we don't need it anymore, because now what we want to do is we want to create an application, an Express application. We're going to do that by creating the Express application. And just to do it really step by step, what I'm gonna do now is I'm gonna say that our application for all the requests that are coming to, let's say, GraphQL, let's simply return hello world, and then we're going to console log API running on, and we're gonna do local HTTP localhost, and we need to do a up.listen to start listening to incoming requests, and here we need to provide the port. So let's provide port 4000. And here in this console log, I'm also going to do 4000. So let's go ahead and not even /GraphQL, but yeah, just simply all the requests that are coming to the /endpoint should return hello world. Not even sure that it's going to work, but let's try. So let's do node server. And we see that our API is running on localhost 4000. If we open this in browser, probably it's not going to work because we need to return a response. I wanted to do it step by step, but better than that, what I'm actually going to do is I'm going to right away create the GraphQL handler. And the GraphQL handler, we want to mount it on the /GraphQL. And the handler will be created using the create handler. And here in the options, we need to provide two things. We need to provide the schema, which has the name schema. So I will have to do schema is equal to schema, and then root value is equal to root value. But because they have the same names, the key and the value, I can simplify it like this. So now our GraphQL that is being served over HTTP is listening to requests on the GraphQL/GraphQL endpoint. So what I'm gonna do is I'm gonna stop the server, run it again, or even better, but I'm gonna show you a bit later. And let's go in our browser, and if I open localhost 4000, we see that we cannot get here. But if I'm gonna do /GraphQL /GraphQL, we're gonna get an error, right? Come on. Why it takes so much time? Did I forget something? API listen. Oh, the create handler should be imported a bit differently. So yeah, the create handler, I forgot. Shouldn't be imported directly from GraphQL HTTP, but from the GraphQL HTTP /lib/use/express. And now I'm going to restart the server. And in order not to have to restart the server always, we can add the --watch here, and notejust now can automatically restart the server whenever we are doing some changes. For example, if I'm gonna do here hello world 123 save, it automatically restarts the server. Now if I'm gonna go to the localhost /GraphQL, we should see the message, we should see back like the error with a message missing query. But if I'm gonna add the question mark query equal hello, and I know you cannot see it very well, but the answer is hello world 123. And I'm going to add it here just for you to see what. Let's do it like this. Test, and I'm gonna do it like this. So you can see the test request that I'm sending. I'm sending a GET request to the GraphQL, and because that's what that's the endpoint in our Express application, then we are sending the query directly through the URL parameters. And here we are querying the hello field from our query here. If, for example, we want age, we can change here age, or even do hello, age. And now if we look in our terminal, we can go ahead and press on this URL. It opens up and our data result has both hello and age. So that means that now we have a fully working GraphQL API, which is running locally and can serve requests. Whenever we are sending this request here, no matter from where, from our application, if we have access to our local host, we're going to be able to get the data. That's not usually how it happens, and there are tools that allows us to interact with our GraphQL API from a visual interface. These tools are great for both backend developers to test their APIs, to run queries against their APIs, and also they serve as a great resource for front-end developers to build first their queries before integrating them in the application. So one of these tools is Graphql, and it looks something like this. So if you saw this interface, this is an open source tool to build and interact with your API called Graphql. When preparing this tutorial, I actually found a better solution for a different graphical interface, basically a different distribution of GraphQL, and it is called Ruru. So let's go ahead and install Ruru npm in our application and add it in order for us to have a graphical interface to interact with our API. To do that, what we have to do is I'm gonna stop this server probably, and I'm gonna run npm install Ruru. Then also from the GraphQL here, let's go ahead and import. Not import, I always do import. It's not a module yet. So let's do require ruru/server, right? And the value that we want is run HTML. Is it Ruru HTML? Not run. Now we simply have to use this Ruru in our Express application. Let's copy it from the documentation and let's add it after our GraphQL here. So what we are doing here is whenever we send a GET request to the /endpoint of our API, we are going to handle this through the Ruru HTML, and this Ruru is going to connect to our /GraphQL to send it to our GraphQL API. Now, if I'm going to go ahead and do node watch server.js and open up localhost 4000, now we should see an actual for you should see a lot of comments here. But this is the visual interface with which we can interact with our server. What we can do is, first of all, we see it as we use it in a lot of cases as a documentation of our API and what's possible. So if we open the first tab here, we see the documentation and we see that we have a query here. If we press on the query, we see that the query has two fields, the hello and the age field. So what we can do next is through the builder, through the explorer, we can create a new query. For example, my query that will query the age and maybe the hello. If I execute this query on the right side, we should see the result, the data that was returned. In a lot of cases, I'm not going to do it through the explorer for checking these boxes. I'm going to right away write it here. So the minimal query that you can run is opening the brackets and now specifying the field from our queries that we want to execute. The field is, for example, age. So if I do that, that would be data age, or the field can be hello in our case. We also get auto completion, hello world. So this is the minimal query. But sometimes we can also name this operation, and it's advisable to name them, especially from client side, because with naming them, we can also use variables later and so on. So to name the operation, first of all, we need to specify the operation type. The operation that we are executing can be either a query, which is supposed to get data, or a mutation that we're going to learn a bit later that we're going to use to create or update data. So by defining it as a query, here we can specify the name that we want to give for this query. My first query. Then opening the brackets, or not even opening the brackets because we already have opening brackets, right? I can execute it and it's the result is the same, but now this is a named query. And later on, we're also going to be able to provide here variables. Age, for example, data age. Perfect. So going forward, we're going to use this graphical interface to interact with our GraphQL API as we will build and as we will add new features to it. Perfect. Let me go ahead and do git add and git commit. Perfect. Let's talk a little bit about different, where is it? Let's go here. I'm gonna close some of the stuff. And let's go into the getting started guide. In the GraphQL clients, here it's explained how we can interact with our application. We are using a version of GraphQL. You can also use Postman or Insomnia. Insomnia was really great when I was working at the previous startup. I used Insomnia because back then Postman didn't support GraphQL API, so Insomnia was great, but GraphQL is perfect for a lot of use cases. When we're talking about client-side libraries, in that situation there are a lot of choices there. You can go with Apollo client to query and fetch a GraphQL API. You can go with Relay. You can go with, the focus of today's video is not going to be on the GraphQL clients. So let's go ahead and continue to the next documentation, which is about basic types. By default, GraphQL supports the following scalar types or basic types. We saw the string and int, and there is also the float, boolean, and ID. So for example, if we have here, let's say we have string, we have age int, we can have also, I don't know, weight as float, and boolean is over 18. Let's do here boolean. So we can return this from our API. And let's do it like this. So our API is supposed to restart automatically. So after all the changes, we simply have to save a file and go back to our graphical interface here. Whenever we do some changes to the schema, we can press on this icon to refetch the GraphQL schema. Because now if I'm gonna do here wait, it's gonna say that there is no operation wait on type query. After I press on this icon, it's fetching the new schema, and now it knows that there is a wait. And I can also do a is over 18. If I send, that's the values that it returns. So this, in a short, these are the these are the 4 most common scalar types that we are using in GraphQL. We can create and define our own scalar types, for example, a date scalar or something else, but I'm not gonna cover that at this moment. In other cases, we will create custom objects. For example, a user would be an object that has like name, username, password, and so on. That we're gonna cover in a moment. But before we go to the next step, I want to mention that all the scalars that we see here, they are nullable. A nullable value means that we can simply return, for example, null for the weight, and that would be perfectly fine, because by default, these scalars are nullable. If we want to make them non-nullable, I'm pretty sure I'm pronouncing it wrong, then nullable. But go with it. If we want to make a field non-nullable, we simply have to add the exclamation mark after the type that we specify. So now if I'm going to execute this query, we're going to see an error that it cannot return null for a non-nullable field query weight. So in this situation, we must return a number. So this is just to understand that if there is no exclamation mark, that means that that value can be null. And if there is an exclamation mark, that value is required. We are calling it non-nullable, but I think it makes more sense to call it required and optional. So no exclamation mark, that means optional. Exclamation mark, required. So that's very important, and that is also like the contract, or the promise that you are making to, let's say, the front-end developers, saying that, hey, whenever you're going to send this query, no matter what, I'm going to return a float value. Even if I don't have it, I'm going to return something there, so that on the front end, we can be sure that when querying this weight, it's going to be a float and it's not going to be null. So we can safely do some operations with that weight. That's great because it creates like a contract between the front end and the back end, something that you cannot easily do with a REST API. All right, so that were the basic types and also the nullable and non-nullable types. There is also a way to create lists. In GraphQL, they are calling it lists. I would call them arrays. For example, if we want to create an array of hobbies, the hobbies, if we want them to be string, for example, they should be string, all we have to do is, well, usually you'd expect it to be like something like in JavaScript, it's an array like this. Well, it's a bit different. The only thing is that the string goes inside these brackets. So if it goes inside, that means that the hobbies is an array of strings or a list of strings. So let's go ahead and add the resolver for our hobbies, because without that, our array, if I'm gonna do hobbies here, refresh, send, our hobbies array is going to be null. Let's define hobbies here, which is going to be a function that is going to, let's say, return, I don't know, karting and F1 and the simulator. These are the hobbies that we're gonna return. So if I go back here and I'm gonna send the request, we see that the hobbies is indeed an array of strings. While we are still here, like the concept of lists probably is not that complicated, but sometimes there might be some confusions around whenever we want to make them required or non-nullable, because there are two things that we can make required here. Firstly, we can make the whole hobbies array required by putting the exclamation mark after the array. What that means is that if we forgot, for example, to define the resolvers, and if we send this request, we're going to see cannot return null for non-nullable field query hobbies, meaning that the hobbies, no matter what, it should return an array. It cannot return null. But the values inside here, which we define as string, they still can be null. So I can still have null here. And the API will not complain. I can send it. We see karting, F1, null, and then simulator. If you want the values inside the array to also be required, you add another exclamation mark after the string. So as you can see, we have a required array of required strings. So now if I'm going to send the same request here, we see that we cannot return null for non-nullable field query hobbies, which means that we cannot have a null value here. So that's the two things that we can make required: the array itself and the values inside the array. Okay, what's next? Let's go ahead through the documentation. Okay, the next step is the arguments. Very important step. In a lot of cases, when we execute, let's say, queries, or especially when we execute mutations, we want to send some data to the server. For example, for a query, let's say if I want to execute a query hello and also provide there the name of a user, I want to be able to send this name as a variable to our query. Let's see how we can do that. Let's add it to the hello. And yeah, I want to say hello, let's say hello plus username Vadim, but in the hello, not world, but hello and Vadim. So now if I'm gonna execute the hello, it's going to say hello Vadim, but at this moment, this Vadim is hard-coded. I want to send it from our query, like when we execute the query. To do that, we first need to specify the arguments for a field. Well, in GraphQL, everything is... in GraphQL, we have types, and in this situation, the query is a type, and we have fields. Every field can have arguments, no matter how deep or how nested it is, and we're gonna see that a bit later, but that means that the field hello can have arguments. To do that, we specify them in a similar way how you would define the arguments of a function. We open the brackets, and here we specify the name of that argument. Let's call it name, and then we need to provide the type of the name, or the type of this argument. So our name should be a string. That's the first step. The next step is how do we get these arguments inside our resolver? We get that, as you can guess, through the first parameter here. So if I do here args, I can expect that there will be the args.name, because that is how we called our argument, name. So I can return instead hello and the name that was passed through the arguments. Let's see if our API was restarted successfully. It was. And let's go to our graphical interface. And if now I'm gonna send this one here, we see hello undefined. Why? Because we didn't send any names there. One way would be to make this argument required by specifying that the name should be a string and it should be non-nullable. In that case, GraphQL will prevent us from running this query and will return us an error saying that the hello should have an argument name. And if I'm gonna actually refetch our GraphQL schema, the graphical interface, the RURU, is actually saying us that the field hello argument name of type string is required, but it was not provided. So to provide it, we simply open the brackets, we specify the name of our argument, and then the value, for example, Vadim. Now if I'm gonna run it, we see hello Vadim here. Perfect. This is a simple way to send arguments, but what we have done so far is we actually hard-coded this argument inside our query definition. When you're going to execute this from your client side, from your application, you're going to copy this query and we are going to define it there. By having it hard-coded here, first of all, the query becomes not reusable, because if we want the user to type his name and then to send the query, we're not going to be able to reuse it. So what we should do instead is we should use variables, query variables. To define a query variable on our query itself, let's go ahead and define it. We will define the variable with a $sign. So let's call it $name, and we need to specify what type it should be. The name should match exactly the type of our variable that we want to use. Should be a required string. Let's say string required. Now we take this $name and we send it to the argument name of our hello field. Now if I'm gonna execute it, we're gonna see that the name was required but was not provided. Yeah, because we just defined it, but we never specify what the value should be of this name. We can specify variables by opening the variable tab here at the bottom and providing a JavaScript object with all the variables that we need here. For example, name, and we're gonna provide the name Vadim. If I execute it now, we see that the name from here, I mean Vadim, the name from the variables object was sent to our query here, and from our query it was sent to our hello field, and from our hello field it was sent to our resolver through args, and it was used in the resolver for something. Like later we're gonna use it to fetch data. For example, you can send ID like this and so on. And in a lot of cases, we simplify this by destructuring it right away. So instead of taking args.name, we can destructure the field name right away here, and it simplifies it because we see that the hello has a name here, hello is using the name here. And it's going to work as it was working before. Alex, hello, Alex. And that's everything about arguments and variables in GraphQL. Let's go ahead and do a git add, git commit, query arguments, or just arguments. Perfect. Any questions so far, guys? If not, let's continue. The next step. What would be the next step? So we learned about this. Object types. Okay. Okay, when we have all right, so let's talk about the object types. I'm gonna start with a very simple and basic object type, and then we're gonna slowly move away from to different way of defining our schema. But at the core, we learned about the default scalar GraphQL types, which are string, integer, float, and boolean. In a lot of cases, your objects will be much more complex, so you have to define your own object type. For example, you have users with their fields, you have posts with their fields, you have comments, and so on. So at the core, our object type is a custom type that we define that is built of other scalar types or even other object types. To do that, we define them in a similar way how we define the type query. The only thing is the query is a default type, but the rest that we're gonna define is going to be created by us. For example, we can define a type here, user, and we can specify that the user type will have a next fields, ID of type integer, and let's say name of type string. Having the user type here, we can define a query called user that will return the user type like this. So now all we have to do is we have to define the resolver for our user query. Let's go ahead in our root values here, and we can say user is going to be a resolver that will return the following object. The GraphQL type object maps directly to a JavaScript object, so we simply have to return an object where we have ID and name. So let's return here an object with ID 1 and name, let's say Vadim. A lot of things are hard-coded, but that's with a purpose, like to keep it simple. Let's go in our graphical interface, let's refresh here. And instead of querying the hello query, let's go ahead and query the user. And now, if you look before, we simply queried the hello. If we query the user, which is not a scalar type, we're not gonna need even the name here. The GraphQL doesn't allow us to query user because user it automatically refreshed it for us because user is of a type other than a scalar, so it's a custom object type. So we need to specify what fields from the user we want to get back. For example, if I specify only the ID here and run the query, we're gonna see that we get back the user with ID 1. We can optionally also add the name of the user, and here we're gonna have a name Vadim. The same thing, for example, for a post. You can define a post here, type post, ID, integer, but I'm not going to overcomplicate this right now. Yeah. Okay, so this was our custom type that we defined. We have a type with their fields, and the fields have their own type. Again, the fields inside a custom type, we saw that they are scalar here, integer, string. But they can also be mentioning other types. For example, a user can have posts of an array of posts. A user can have friends, which is an array of other users. A user can have, I don't know, invited by, which is just a user. So as you can see, by specifying types and the relationship between the types, we create this graph from where we create the graph of data and all the connections between this data in a simple and easy way. And then the front end, for example, can create very complex queries to get the data that they need. The problem is that these connections, like to posts, to friends and user, the connection between types, I was not able to create them by default with this approach, where we have a schema and the root value. Because root value is providing all of this data to the queries. What I need is I want to provide custom resolvers to some of the fields. For example, in the user, I want to have here a posts that will return an array of posts, but this post should have a custom resolver to tell how should we get the array of posts knowing a user. So to provide custom resolvers in this situation, what we can do is we can create the schema a little bit differently. Instead of build schema from GraphQL, what I'm gonna do? let me go ahead and comment out our existing schema here. And let's go ahead and start creating the schema using the GraphQL schema imported from GraphQL. It should be an object. So we create it using the GraphQL instead of a build schema. This is a class, so we are initializing it with new. Everything starts with a schema, and the schema should have the queries, which is going to be if we look in our schema that we had before, our query is a type, is an object type, right? So the query will be a new GraphQL object type, also imported from GraphQL. So the object type here will have two things: the name of the object. So the name of the object is going to be this one. This is the name that we had before. The query type, and it's going to have a list of fields. So a type has the name and a list of fields. The fields, we can start looking into this query. Well, there is the, let's say, hello, and I'm gonna start with a simple hello world. The hello is a string. The hello field should return a string, right? So let's simply say that the hello is an object where we have a type, GraphQL string, another object imported, another class imported from GraphQL to specify that the hello is of type string. And here is where we can provide directly the resolver. So the resolver is the function that previously we defined in a separate place, but now we can define them together. Hello world. So just like this, we have a schema with queries, with one query called hello that returns a string. We don't need the root value anymore, so I'm going to comment this out. And in the create handler, the only thing is that I have to remove root value and only leave a schema. The GraphQL, it allows us to add resolvers even to custom types. For example, I wanted to show you this in order to show you how we can create like custom resolvers to connect like a user and a post. But to be honest, I don't even want to continue because this way of creating is, first of all, very verbose, a lot of code, a lot of configuration, very easy to get confused, and also same could be accomplished here. You don't have to follow along, but just have a look, and then we're gonna see a better approach. For example, if I want to have a query to get users, right? Let's focus on getting users, for which we need a custom user type. To do that in our schema, besides the query, we are also, besides the query, which starts here and ends here, we are going to have another type called user. Or let's even create it separately. For example, we can do that by creating the user here using new GraphQL object type. The object type has a name, and the name, we're gonna call it user, and it has a list of fields. It has fields, which is an object. The user has two fields, ID and name. So let's do ID. Our ID is an object where we have type, and the type is GraphQL int. Is there a GraphQL int? Probably. And the resolver, well, yeah, in this case, I don't need the resolver, and I'm gonna explain in a moment why I don't need the resolver. And the second field that our user has is a name, and the name has a type of GraphQL string. So now that we define this object type here, we can go ahead in the query, add in the fields of a query, add another query. As you can see, like, it's very hard to map, even for me that I have a bit of experience with GraphQL, it's very hard to map like where should we add things. But in the query fields, after hello, so we need to see where hello is ending, it's ending here, we need to add a new query called user. This query, the type, the return type of user, again, I'm gonna reference back our easiest type definition at the top that we're not using anymore. The user query will have a return type of user type. We created this user type here, so let's specify that the type will be user. And we need to provide the resolver, how to resolve it. So the resolver is going to be very similar to how we had it before. Basically return ID1 and then the name. So just like that, if I didn't make any mistakes, any typos, our server should be restarted, and I can go back, I can restart, and besides hello, I can also query the user, and the user will have an ID and will have a name. So if everything is working, it should return ID1 and name Vadim. That's good, but again, it has a lot of boilerplate. Anyway, we are doing this just to learn the fundamentals. Shortly, I'm going to show you a better way using a simple library, how we can do that much better. We think what a GraphQL object type of this structure will allow us to do is provide custom resolvers. First of all, you might think why we didn't provide a resolver for the ID and the name. Well, we can, for example, in the name, if I provide here a resolve value that will return overridden name. Is that how you write overridden? Probably not, but you get the point. If I'm gonna send this request again, we see that the ID remains the same, but the name is overridden. So the name is not the name that we get from the user resolver. It's the name that we get from the resolver of the name field. Why it was working before without a resolver, GraphQL is smart enough to say that, hey, if there is no resolver, we simply will take the value with a field name from the parent. So from the whole user object that is this one, we're gonna check the name and we're gonna resolve to that one. So if we don't need to do any changes to that value, we can have it here. We can leave an empty resolver and GraphQL will simply take that value and will return it there. But in GraphQL, we can provide resolvers for every single field, no matter how deep and nested they are. So that's where a custom resolver can be handy. For example, what we might do in some situation is, let's say we want all the names to be with capital cases. Like instead of this, I want to make sure to trim the string and also to make it capital. Like if the database will return something like that, I want to, from the user type, to always trim and capitalize the string that we want to return. We can do that here in the resolve, but first of all, how do we get access to the name? We get access to the name through the first parameter of the resolve here, which is called OBJ. The object is basically the object representing our parent object. So if I simply will say obj dot, again, if I have return override the name, it returns override the name. If I will do obj dot and the field from the parent component that we want to return is called name. If I do that and run it again, we see that the field is returned as it was returned from the user resolver. But we want to, for example, trim that string to remove all the white spaces from back and front. That's a very common way to provide a very simple resolver for a field, and make sure that always when we query the name of a user, it's going to be trimmed. No matter where it's taken from, it's going to be trimmed. And also you can do, for example, to lower case. Is there such method? Yes. And if I will do to uppercase, it's going to be all capitalized. So just like that, we saw how we can provide a custom resolver, and we understand how we can access the parent fields from the resolver. So here we are working in the resolver of a field called name, and the object represents the parent. And to demonstrate that, I can do a console log obj. This, if we're gonna look here when sending this request, we're gonna see that the value that it gets is the value of the previous resolver that was executed. And the previous resolver that was executed is this one of a user. So sometimes it might even have extra things that might not be in the type definition, but for example, in the database Vera, hey, and with these extra things, if I send the request, I might not need them to necessarily return to the user, but I need them to do some operations. For example, I might have the isAdmin, isAdmin equal true. So if, for example, from database, when getting a user, I'm gonna have a isAdmin true, I can access it through the object resolver of a name, and I can say const. Let's do some interesting use cases here. Let's say if obj.isAdmin, the name will always contain admin word. So I will say return name, not name like this, but the name variable, and then admin. Otherwise, I'm gonna simply return name. So you're gonna see that even though our schema that we can look at the documentation here for the user, it never mentioned like is admin or not, it only has ID and name. We used like some data, some properties from our previous resolvers to adjust how we return the name. So now we see that Vadim admin, just because the previous resolver has this isAdmin true. If it would be false, and I would send it again, I will see only the name, because that's the logic that we added. So that's a little bit of how resolvers are working and how they are executed one after another. So whenever we send a query, GraphQL will start from the topmost query. So first of all, it will look at the hello, and it will look for a resolver for this hello field. It will check our schema, and in the fields, it sees that the hello has this resolver. It will return hello world, and because it doesn't have any sub fields, it will stop here. It will go to the next one. The next one is a user. Well, let's go ahead and look for a resolver for this user field. And in our schema, the user has this resolver. Let's execute it. And then for every single field inside the user, let's find the resolver for that specific one. For the ID, it will take this object and it will go to our object user type, look at the ID and look for the resolver. It doesn't have a resolver, so it simply will return the field from the parent resolver that has the same name. So it will simply return 1 in this case. Okay, it resolved, like it got the value ID. It doesn't have any subfields. It will stop here. That means that it's a edge field. It will go to the next one. Name, it will go again. In the user object, it will look at the name field and will check if it has a resolver. Yes, it has. It will call this function resolver by sending to the object the previous object that we saw before. So in this object, we're going to have access to all of this data and we can do some logic with it. In our case, we saw how we can process some strings. Sometimes maybe you can add like a very common use case is to add if you're displaying a price, the price can be an integer or a float in your database, but when you return it to the customer, you can automatically transform it to a string and also display the currency there. Another very common use case for custom resolvers for a user is when, for example, we have the user, maybe that one I'm going to show you later, when we have a relationship between custom types. For example, a relationship between user and post. When a user can have multiple posts, a post belongs to one user. In that case, we need a custom resolver to tell, okay, knowing the user ID, how should I go and get information about that user? But we're going to see that a bit later because I'm really tired of seeing this syntax of GraphQL objects, GraphQL strings, and so on. I much more prefer the previous way of having a schema as a string because it's very clear what fields a user have. If I look here, it's clear. The user has ID int name string. And when creating a query on the front end, I can literally come copy it from here and paste it in my query and just remove the types. That's all it takes. With the other one, if I look at this object, it's not very clear what fields it have. Yes, I should focus fields. Okay, it has ID, it has name, but when it gets complicated, when it gets long, it becomes very hard to manage. So for that reason, in the next step, we are going to use a light library to define and create this GraphQL API. But before we do that, let's go ahead and do a commit. And this was, let's say, GraphQL schema. Kirtan, thank you very much. Krishna, thank you. Dhananjaya, hello. Techie Code, how are you? The question is, in your React Native course, is Redux included? No, we do not teach Redux in our course. We are teaching Apollo client because that's a much better way to query a GraphQL API, and also Apollo client serves as a global, it has a caching mechanism. So whenever you're working with mostly remote data, besides the the fetching library that also has like caching possibilities. You do not really need extra global state management. So that's why. And if anyone is interested in learning and becoming a React Native developer, check out academy.notjust.dev, where you can learn how to build full stack mobile applications with React Native, Expo, and AWS. It contains hands-on projects. One of them is super big, like you basically would build like a full Instagram clone, both on front end and back end, with a scalable AWS architecture. So yeah, we have more than 700 students, and yeah, it's very powerful and will help you master these technologies. So check it out, should be in the description below. And we are actually ready to move to the next step. There is also, like, from the fundamentals, the mutations and input types, but we're gonna get there once we get rid of the GraphQL schemas and so on. So the library that I'm gonna use, if we go to the GraphQL, let's go ahead and check code. And let's sort JavaScript by popularity. And after GraphQL here, after Apollo server, we see Graphql-yoga. This is the first time I was trying Graphql-yoga, and actually it was very lightweight and very performant and very easy to set up a GraphQL API with this library. So let's go ahead and follow their instruction to set it up. And the GraphQl-yoga is going to replace our GraphQL HTTP. So instead of GraphQL HTTP, which is really basic, we're gonna use this much more powerful library that is also suitable for production applications. So all we have to do is add GraphQl-yoga or install GraphQl-yoga in our application. So let's do clear and let's do npm install GraphQL/yoga. And with GraphQL-yoga, not Yoda. With GraphQL-yoga, we have this split of type definitions where we write them as GraphQL strings and our resolvers. So we can get back to our type definitions, and it's going to be much better. So I would say let's go ahead, and I think the best way is going to be to clean up a bit our code. So let's delete some of the stuff just for us not to get confused, and we're gonna recreate something as we need. Hopefully we're not gonna get let's do that. We will still need the Express application. The only thing is here, we're gonna have to replace this GraphQL with Yoga. We're gonna leave our Ruru GraphQL interface, and we're gonna start the server here as it was working before. Now I'm gonna also fix a little bit our imports, and maybe it's actually time to, as we have a clear application, to switch to a module to be able to use import statements. For that, let's open package.json and simply add here type module. Module type will allow us to, instead of using require, to use our traditional import express from express, and the same here, import Ruru from Ruru. And just like that, if I open it up and see the server is restarted, it's working. If I'm gonna refresh here, our probably it's not gonna work because we do not have a GraphQL endpoint yet. Yes, that's true. So let's go ahead and check the documentation of Yoga, and I'm going to copy these two things. So we have to import create schema and create yoga from GraphQl-yoga. We create the yoga, then we provide the schema definition here. A schema has two things. It has type definitions and it has resolvers. And because it has this comment here, GraphQL, it adds highlighting. Because if we don't have this one, it looks like a normal string. And in some cases, yeah, like highlighting is much better because it's more clear like what are our types, fields, and so on. But I'm pretty sure that this is coming from some of my extensions. So if you don't see it, make sure to have GraphQL syntax highlighting. And I don't have it, so I'm not sure if maybe it's built in VS Code. Maybe I have this one. Yes, GraphQL language feature support. Yeah, most probably it's from here. If I check the enabled GraphQL, that's the two things that I have. The language feature support and the syntax highlight. And this allows me to highlight my GraphQL type definition by simply adding the GraphQL comment here. So now that we have yoga, all we have to do is we have to uncomment the app/GraphQL, and instead of create handler here, send there the yoga application. So that's how it looks. And if I go to our graphical interface and refresh it here, we're no longer going to have a user, but we're going to have a hello. And if I'm going to run it, we see hello from yoga. That's it. That's our simplest yoga setup. But it's going to allow us to have like type definitions and separate resolvers. So before we move forward, let's go ahead and set up a little bit of our project structure, because going forward, we're going to learn how to interact with MongoDB, with a database. We're going to have a very realistic use case, and we're going to try to build it as close to a production-ready API as possible, still keeping some of the things simple and accessible for everyone. So for that reason, let's go ahead and define a new folder where we're going to keep all the source code. It's going to be much more manageable if we separate some of the concerns, not to have all the source code in the same file. So in the source, we're going to have, first of all, we are going to have a folder called GraphQL. And in the GraphQL, let's create the index.js. GraphQL index.js. Not even sure what we're gonna have there, but maybe in the index.js of GraphQL, let's go ahead and move our yoga there. Or no. Or maybe the schema. Yes, let's move the schema here. So in the index, let's go ahead and do const schema, or let's call it schema, equal to create schema from GraphQl-yoga. And here we're going to basically, let's copy it from here, create schema. Let's go in our GraphQL and call it like this. Now let's simply export. Let's export const schema from here. Export. So now we separated our, let's say, schema from the rest of our boilerplate just to make our server work. So all we have to do is we are going to, in our server.js, let's import schema from source GraphQL index. Now I'm gonna provide it here in the Graphql-yoga, and I'm gonna clean this up a bit. Okay. Okay, now back in our index here, what we can also do, we can separate the type definitions from the resolvers. Or not to overcomplicate this, we're gonna do that as our file gets bigger. But first of all, let's have a look if everything is still working. So I'm gonna check if our API is running. Probably there is an error here, failed running server, because cannot find module. What? Which module it cannot find? Schema. Is it because of the import schema there? Yep. So if I do import schema from source GraphQL index, export const. Did you mean to import? Oh, index.js it wants. Index.js. That's definitely possible to be adjusted through settings, not to have to specify the extension, index.js, because it should even work like this. It should automatically take it. But anyway, it wants index.js. I'm going to give it, and we're going to continue. And this schema will be passed to the Graphql-yoga. Okay. Now it works. If I go here, I can refresh, and I can still run the hello. Okay, that's good. Let's see how we can add the same configuration that we had previously about the user. So to do that, in this situation, we have to do two things. We have to define the type, the type user, the query that will give us an user, and the resolver for the query. So starting with, let's say, defining the type user, which has ID of type int and name of type string, right? Now in the query, we want to create a new query that will give us a user back. Maybe later it's going to be give us user by ID, but now to simplify it, when running a query user, we want to get back a user object. For that, we need to provide in the query here the user resolver for our query. The user resolver will return an object with ID 1 and name Vadim. Just with that, I can go back here, I can refresh, and I can start querying our user with its ID and with its name. If I run it, we have it here. So you saw how much easier it was right now to define a new type, a new query, and the resolver for that query compared to how much more complicated and more boilerplate we used whenever we used the GraphQL HTTP library. So as you can see, now it's much simpler like this. And if we want to, for example, capitalize the name, we remember that we have to create a custom resolver on the user type and the field name. For that, below the query, because the query is the first type, which is the default, so below the query, I'm going to define a resolver for our user, and the resolver for our user type will specify, the user will have fields. So one of the fields will be name, and the name again will have an obj object from. I hope not everything is good with our stream, you know? I see no data. Okay, now it's back to excellent connection. Not sure what's going on today, but anyway. Again, how much easier it was to do it here than we had it before. What I want to probably try to do right now is to split type definition for different things. For example, I want to split the queries about users and so on into a separate file. Let's see how easy it is going to be, and I hope I'm not going to confuse you too much at this moment. But the thing is that as we will write more types and more queries here, more resolvers, it's going to get this file is going to get really huge. So for that reason, let's look at how we can split it using Graphql-yoga split schema. It's not stretch, but stitch. So combining local and remote schemas, no. Let me check the documentation to make sure that if there is a specific way to do it in Yoga. Maybe some of the examples. Express should probably be very simple, yeah. Build application. Type definitions. Resolvers, yeah. Let's check their website. Because most probably this is not the responsibility of Yoga and we should simply merge together two objects. But yeah, let me double check that here. GraphQL features, schema. Yeah, the thing is that Yoga doesn't care about schema. As long as you give it a schema, it's going to work. But the other guides and solutions here from the guild. So let me see and let me think. Resolvers. Yeah, it's going to be merging the resolvers, and for the type devs, it's going to be providing them like this. So let's try by splitting the type divs. I'm not sure this is for a poll. This is actually for something else. But let's see if it's going to be the same here. So type devs, can I do here? For example, let's do here queries, and let's move everything from type devs to equal here. Now, if I'm going to simply provide queries here, it's supposed to work because we simply took it out of there. So now if I run, everything is working. But if I'm going to separate the type devs into two things, the queries type devs and the user type dev, and if I'm going to copy it from here and in the, oh, come on. And now from the queries, if I'm going to remove a type user, and if from the user type dev, I'm going to remove a query, will I be able to pass to the type devs an array of things like queries, and then user type devs? Let's see, it's restarted. So if I will execute, it still works, which means that it's good, because if the type, if I would have here a different name, we would see that it's an error. So it gives me an understanding that it's splitting the type definition into different objects and providing them to our schema as an array works great. But sometimes in the user type definition, I also want to keep all the queries related to the user. So if I'm going to do here type query and say that there is a query user and I'm going to remove it from the first one, it's not going to work because we are in a way we have two type queries and there would be a clash, and I would expect it's not going to work. But actually it does. What? Okay, I think that yoga is that smart to do, because I was expecting this to work like this, extend type query. I remember that's how it was working. So I think yoga is smart enough that if it sees that we provide in two different parts the same type, for example, type query, it's simply going to merge them together. It's going to extend. In our cases, you'd have to simply say extend type query by providing additional fields in the query. So now we keep all the type definitions about the user here and the rest in the queries. That's good. So that would mean that we can, in the GraphQL, we can create a new folder called models maybe, and we can have here a file called user.js. In the user.js, I can extract the type definition of our user, and let's export, how would I call it? Import type def, yeah. I think to keep it simple, I'm going to export it with the name type def. So let's export const type def from this file, and now in our index, we simply need to import it. To import it, let's import it as following. Import type, come on, type def from models then user.js. Now I can take this type def and provide it to the array of type definitions. Everything is still working. Let's double check that. Yes, it's still working. And usually we would have to rename it just because we're going to have a lot of type defs from the user, from the post, comments, and so on. So let's rename it to user. Now we successfully have split the type definition of a specific model of a user, for example, including his type and his queries into a separate file, imported it here where we create the query. That's good. Now the next step is to extract and export the resolvers. Resolvers in our case is an object. So let's go ahead and extract them here. For example, const resolvers equal, and I'm going to copy the whole object resolvers like this, just taking it step by step, and this way, if something fails, I know at what step it failed. Now it failed. Why? Because resolvers, create schema. Oh, because I have a comma here, and now it works. Send, perfect. So, tip of the day, take it step by step and test all the way. Now, from these general resolvers from index file, I want to extract resolvers related to the user, specifically this one from the query and this one for the user. To do that, I will have a separate const user resolvers equal to a new one. This one, first of all, is going to have this object about user. That's clear. But it will also have the query user. So it's also going to have query and the user. Query user like this. So now these are the user resolvers. These are general resolvers. And what we should do is basically we should merge them together. To do that, we can simply import the merge function from Lodash because we need a deep merge. We need basically, if a shallow merge will basically take the user and put it here, and maybe we'll take the whole query and replace it here. But what we want is we want inside the query to take the field, put it here. So it's basically we need a full merge between two objects. To do that, we can take advantage of Lodash library. So let's go ahead and install it quickly by doing clear import npm install Lodash. And then let's import the merge here. Import merge from Lodash. Now what we want to do is in our schema, we want to merge. What do we want to merge? First of all, resolvers, the default ones, and then user resolvers. And now everything is working. The server is restarted. No, because merge, import merge from Lodash. What? Should work. Come on. Lodash is a common JS model which not supported exports as name export for. Okay, I'm gonna import Lodash as underscore, and I'm gonna use here underscore dot merge. Okay, perfect. So now if I go back to our interface, everything is still working. But the cool thing is that we have separated the resolvers, our general resolvers, from our user resolvers. And now I can take them from here and move them to our user model. And our user model will simply export. And I'm not going to call them user resolvers. I'm going to call resolvers. And when importing it in our index, let's go ahead and import them from user as resolvers and rename it to user resolvers. And just like that, we have a very general file for our schema that is supposed to simply put together our schema. We can have here, for example, very general types like type, genre of movie and so on, or union, or things that needs to be in every places of our API. But when talking about like specifics, for example, the type definition and the resolvers of our user, we're gonna simply go here and at the top, we have a type definition. We know that a user has ID and name, and we can query a user, and we see the resolvers, how we can do that. So just like that, it's going to be much cleaner and easier to scale it as we will add different models in our application. So let's go ahead now and do git status. Let's do git add, git commit. We're gonna do Graphql-yoga. Perfect. And the next step is going to be to probably already start thinking about a real use case and interacting with a database. But before that, I need just a minute and I'm gonna be back. And if you have any questions, feel free to ask them. All right, so I am back. And yes, let's continue the tutorial. And actually, before going ahead and starting like integrating this GraphQL API with a database, I want to cover the other important type of operations that we can run in GraphQL. So far, we saw how to run a query. A query is an operation when we have to get some data from the API. Usually, a query should never create side effects. We should never update things or insert things when we are running a query. For that, we have a separate default type of operations in GraphQL called a mutation. And a mutation is there to help us create things, update things, delete things, basically operations that have side effects. To define it, we define it also as a separate type. So let's go ahead in our user, actually. Yes, let's go in our user. And the same way as we have a type query, there is another one that is, the default is type mutation. In the type mutation, we can specify as many mutations as we like. The first one can be create user, and a create user will return back a user. I'm gonna start simple and slowly I'm gonna add more things there. Now that we have a mutation create user, in our resolvers, we need to provide the resolver for that mutation. Well, after the query, where we see the closing, let's go ahead and do here mutation. The mutation has a field called create user. So let's provide here. And the field create user, I think it's also going to have the object as the first parameter, but we're going to check in a moment. So let's do a console log here, creating a user. It should be arrow function. And it should have a comma here. We are not returning anything, but that's okay because the user is a nullable field. Let's just try to execute this function and see the console log in our terminal. I'm gonna go back here, and if I'm gonna try here, I'm gonna refresh it first. If I'm gonna try here to call the create user, it's not gonna allow me because our operation has the type query. I would have to first change it to a mutation, and only then we're going to be able to access the create user mutation. A create user of type user needs a selection set, for example, ID and name, because we specified in our type definition, that create user will return a user back. So if I execute it, it's going to be null, but in the console log, we see creating a user. That's already good. That means that we are correctly executing this mutation. If you see the create user, if not, double check the names and where you create this mutation resolver. Now, if I'm gonna do here console log object, actually I don't need it, but just curious what it is. If I'm gonna run it, we see that it's undefined because because object is basically the response of a previous resolver that is executed, and a mutation is the initial resolver that we are executing. That's why there is no previous resolver being called. Create user is the first one. Now, when we create a user, we most probably would want to specify the name. So we would need an argument. We will need some input here. So let's provide here the input, and we're gonna provide it. We know already from the previous steps how we can provide arguments here. Create user will have a name of type string, and it should be required. This argument we're gonna receive in our resolver as the second argument after the object. So this is going to be our args. If I'm gonna go ahead and console log args, let's go ahead and try to execute this one, but first refetch our query. First of all, we see that create user has a required property called name. So let's give here a name. I can hard code it to Vadim. And if I execute, it's still null, but when we look into the console logs that we are doing here, we should see that the object is undefined, but the argument has this name Vadim. Perfect. So the last step is, of course, as I showed before, would be to provide here a variable to our mutation called name, type string, and it should also be required, and this name would go here, and through the variables we're going to provide the name Vadim. If I do it like this, yes, we have access to it. So usually in this situation, we don't actually need the object argument. So usually you'd see in some cases this one being replaced with simply underscore, because meaning that, hey, it's the first argument, but we don't need it here. We only need the arguments. And from the arguments, we can destructure right away the name. So we can say creating a user with a name. But what I actually can do is I can return insert into database and then return ID, for example, 1, and name that was sent there. So we're not inserting now, but later, imagine that here you'd insert it and then you'd return the result. Now, if I'm gonna create this one, we see that the create user, after executing this mutation, it added it basically to the database, hopefully, and it's gonna do later, and it returns us back the ID and the name that we sent here. And as you can see, this name is capitalized. It's not the name that we provided here. And even if I will add a lot of spaces here, I didn't trim it actually, but I can do it through the user name dot trim. So as you can see, even though in our mutation, in our create user mutation, we never said that this name that is received here, and I can show you in the console log what is the actual name. If I execute it, if I look in the console log, the name is with lowercase characters, and it has some spaces and beginning at the end. We never told here in the return statement that this name should be lowercase or capitalized. But here it is, just because even when returning like the object from a mutation, GraphQL will go ahead and call all the resolvers for that fields. So it knows that the mutation create user will return a user, so it will go take the result that it gets from here, pass it to the ID resolver. It doesn't have an ID resolver, so it's just simply gonna take the ID, go ahead and pass it to the name resolver. Because it has a name resolver here, it's going to apply it. So this way, it's really helpful to only write things once and be sure that they are always executed and made the way you define them. Like that's very true, like with specific fields that you're applying some changes, or with relationships. You simply define the relationship between a post and a user once, and whenever we need and whenever we return a user or a post, we can automatically query the relationship as well. But the point here was about a mutation, and at the core, I mean, from the technical perspective, a mutation is very similar to a query. It has the same syntax, it has the same arguments, it has the same return statement, it also has the same resolvers. Basically, from technical perspective, everything is the same. The only difference is that a mutation is used with an operation type mutation, and it's used with the purpose of updating, deleting stuff. That's the only difference. Technically, everything behind the scenes is the same. When talking about a mutation, we should also understand that it's not the arguments are not always going to be scalars. What if our user has also, for example, age here of type integer? When creating a user, I want to also send age. Well, we can do that here as comma age int, And what I'm going to do in the resolver, besides taking the name, I'm also going to take the age. And here I'm gonna return age, right? So now if I'm gonna go here, I can also specify the age of a user, which let's define properly with a variable at the top, age of type int. Forgot this one, and it should be required, right? Or no? Age and field create user. I need to refresh. And in the variables, let's also provide age here. I don't know, 18. If I'm gonna send, it doesn't show me because I didn't select that field in the result. So let's select it to also return the age. We see 18. But as you can imagine, the more arguments and fields about the user we're gonna have, the more of these variables we're gonna have here. It would be better if we can structure it into a custom type. For example, the same way as we have a user here, it would be nice to have here, let's say, user of type user, right? And be able to take the user directly from the arguments and then providing the ID and the rest of the user here, right? Well, this is not going to work because a type cannot be an input. What we should do, similar to how we have a type, we can define an input. Input, new user, we can even do new user input, and this will have the following fields, name and age. In a lot of cases, the ID is automatically generated, so it's not included in the input. So now, having the input, we can say that create user mutation only needs one parameter, and that's a user of type new user input, and we can also specify that it's required. Here, name and age also required. And just like that, we can come back here, and we see that, let's refresh. The create user no longer needs a name and an age, but it needs a value called user. Let's define it as a user variable. And let's create it here. User of type new user input. It automatically auto-suggested for us. And here it says that the name does not appear in our GraphQL. Yeah, because we need a user here. And the user should be an object where we have a name, this one, and the age. So if I'm gonna make it a little bit smaller like this, now if I execute it, yes, it works. It has the ID, it has a proper name from here. Sorry, and it has the age also from here. And this is a easier way, like we basically group together all the input in one single field, similar to how we group together a type specifying the user. And yeah, later on, like most probably in your front end, you're also going to keep them like this, where you're gonna create them when you want to execute the query, send them here, and it's a much easier query definition, much cleaner. So that's where we have input type. Very similar to a normal type, but it's used for inputs as arguments. Hello, hello. What database do you plan to use? I'm planning to use MongoDB, and that's probably going to be the next step. Are you going to cover all the CRUD operations? Let's try. Let's try to cover all the CRUD operations at least for one model. All right, so that was our mutations and inputs. Let's go ahead and do git add, git commit, mutations and inputs. Okay, so let's go ahead and move on to the database integration. Even though GraphQL doesn't require any kind of specific databases to be used, because at the core of GraphQL, we have type definitions and resolvers, and our resolvers are simple JavaScript functions. So we can do anything in these JavaScript functions that you can do in a Node.js. You can connect to maybe local databases, to SQLite, to remote SQL databases, to NoSQL databases. Basically, you can do anything that you can do in Node.js. For the sake of this tutorial, I'm going to use MongoDB just because, I don't know, it's easy. It goes well together with GraphQL. It's very easy to host it with Atlas. So yeah, let's go ahead and do that. MongoDB is a NoSQL database that's very scalable, and it works based on the documents. The benefit is that we don't have to specify any kind of schema. We can adjust the schema as we evolve our application. So I believe that for this tutorial, where we don't have a very clear plan, it's going to help us manage this data the way we need. The goal going forward is going to be to create an API for, let's say, a social media application, having users, having posts, maybe having comments where users can create comments under specific posts. So let's try to do that, and we're gonna try to cover the CRUD operation for at least one of these models. And also, very important, the relationship between them, because I really want to query a list of posts with the first, let's say, 3 comments, and for every comment to also query details about the user that posted that comment. So all of this we're gonna see how we can do together with a MongoDB database. So let's start by going to mongodb.com, and let's go ahead and sign in. I'm already signed in, or no. I'm gonna go ahead and sign in with my Google. And on the home page, most probably you're gonna be asked to create an organization. I already have an organization. It's nothing complicated, just give it a name. And after you create an organization, inside that, go ahead and let's create a new project. I'm gonna press new project, and I'm going to give it a name for the project, let's say social media. Let's click next. Give member access, okay, create project. And here is our project. The database is not yet deployed. For that, we need to create a deployment. So let's press on this create button under the deployment. And here we can choose a free deployment, which basically is going to be free and enough for testing and learning everything. You can use cluster 0. In my case, it's, I I cannot use that cluster 0, so I'm gonna rename it to cluster 1, and let's press create deployment at the bottom. Perfect. Now the MongoDB Atlas. MongoDB Atlas is a way to create and host our database in the cloud really easily. You can also host a MongoDB database yourself on any VPC, on any cloud computer, or even locally if you install the MongoDB server. But with Atlas, we don't have to worry about that. We host it and we create everything in the cloud. So the first step that Atlas has done after creating our cluster is it added my IP to the whitelist to allow me to connect to the database. And it also, the next step is going to be to create a database user. I can call it Vadim, and let's press create database user. Now that my IP and is whitelisted and also a database user is created, we can move to the next step to choose how we want to connect to this MongoDB cluster. To connect, I'm going to select drivers, and here let's select NodeJS version 5.5 or later. And the first step it tells is that, hey, first of all, install the MongoDB package, the MongoDB driver. Let's go ahead and do that in our project. I'm gonna close everything. I'm gonna open a terminal, and let's start by installing the MongoDB driver. npm install MongoDB. Okay, after that is done, the third step is going to be to get our connection string. Here it shows our connection string, but I'm going to select this view full code sample to show me how I can connect to our database. Let's go ahead and copy this code, and in our project, in the source, let's create a new folder called Mongo. And in the Mongo, let's create the index.js. Here in source Mongo index.js, let's paste the code that we copied. And what we see here is some code that we're gonna analyze in a moment. But first, let's try to execute this code. To do that, I'm gonna run node and then provide the source Mongo and then index.js. If I execute this one, what do we see? We see that, yes, we are not using require, so we are going to have to switch from require to import. So instead of const, it's going to be import, and instead of require, it's going to be from. Just like that. And let's try to run this again. After a bit of time, we hopefully should see that the ping was sent to the server. Yes, if you see ping to the deployment, you successfully connected to MongoDB. That means that everything is perfect. And the second time, it even took less time because it was already warm. So if we look at this code again, what we see is, first of all, is the connection string that has like my username, my password. It's recommended to move this one to an environment variable. Maybe we can cover this a bit later, but for now it's okay. Then it creates the MongoDB client. And when we execute the function run, it's connecting to the client. The client is connecting to the database with the name admin, and it's executing the command ping. And after it sends the ping and receives it back, if it doesn't throw any error, we simply console log this one. And at the end, we are simply closing the client, the database client. So that's in a couple of words what's happening here. Let's go ahead here and do review setup steps. connection string. Done. Okay, perfect. Let's go ahead in the deployment, under deployment and under database. Let's see what we have here. We have a cluster 1, so let's press cluster 1 to see what databases do we have in this cluster. If we look under collections, in MongoDB we do not have tables, we have collections. Here we have actually, maybe we should work with this sample movies. What's this? This is a sample database for us to interact and work with. It's called sample mflix. It has comments, it has movies. So our plan, I think, is going to change very fast because we have a lot of data here that we can work and interact, and maybe we can even add and work from here. As I see, it's a database of movies. It has information about movies, poster, title, language, and so on. It has users, Ned Stark, that's good, Robert Baratheon, and it also has email and password. I'm pretty sure Ned Stark and we're actually with Alexandra started rewatching Game of Thrones. If you're a fan of Game of Thrones, let me know in the comments. The second time watching it, it's like really nice. Like you understand like a lot more of the details there. But anyway, so we have users, we have comments. I think we are going to be able to query and add comments, which is nice. So yeah, let's go ahead and use this sample database. And to be honest, I really hope that you also have this sample database and you're going to be able to follow along. So Atlas, please don't remove this sample database in order for this tutorial to be relatable in future as well. Anyway, let's try to connect to this sample database and send some queries. So the name of the database is called sample mflix. So let's go back in our application. And what I will do here is in our run function, instead of connecting to the database with name admin, I'm going to connect to the, how is it called? Sample underscore mflix, right? That's the name. Yes. Then the command that I want to send there, I don't even need to send a command. I want to access a collection. And the collection that I want to access has the name movies. Movies. Let's do find. And let's the response get. Let's do here movies equal await collection movies find. Now if I'm going to console log here movies, let's try to run again this index.js file to see if we fetch correctly the movies. We see something that's already good, but we need to do find, and the response of the find is going to be a cursor. To transform it to array, I think we have to do toArray, and that will transform it to a normal JavaScript array. Now if I'm going to execute it again, we see an array and a list of movie that was read from the database. Great success, isn't it? All right, that's perfect. So that means that right now we can connect to our MongoDB. So far we have connected to, well, let's do it again. So far we have created a MongoDB. We have hosted it with Atlas, and we have connected to it from our Node.js server. The next step is going to be to provide this database to our GraphQL endpoints or resolvers in order for us to run MongoDB queries directly from our resolvers. For that, we are no longer going to simply run this function, but we are going to do the next thing. Let's do it like this. Client, await client connect. So what I want to do is I will rename this function run to setup database. The setup database should go ahead and connect the client and will not send any requests, will simply return the client. I don't want to close this connection because I need the connection open as long as our server is running. So I'm gonna remove this finally. Maybe I'm gonna add a catch method here in order to catch the errors. And I'm gonna simply console log error connecting to the database. And let's go ahead and remove this run from here. And what do we have? We have a function, async function setup database that we want to export. So let's go ahead and do export, or let's call it here export async function setup database. Okay, now we need this client. We need it inside where? We need it somewhere inside in the resolvers of our users. For example, when we call create user, we need the client in order to insert it to the database. So we might try to call it here, for example, setup database to get the client. But the problem is that this setup database is going to be called too often in a lot of resolvers. It would be better to call it only once and provide the database or the client of a database to all the resolvers through some kind of a context. To do that, we can easily do that inside our GraphQL index, because when we create the schema here, after the resolvers, we can also provide here is it here? No, it's not here. It's actually in the server.js where we create yoga. When we create yoga, besides the schema, we can also provide here context. And the context can be any kind of, it's an object containing any kind of fields like hello, and the value will be world. What? Context? I think the context should be a function that will return an object, right? I don't know why it doesn't like the schema, but yeah, hopefully it's just some TypeScript. But anyway, the context will return an object, and this context is going to be accessible in any resolver of our GraphQL, in our GraphQL resolvers. To demonstrate you this, let's go ahead in our models, user, and when we call create user, we can get access to the context as the third argument. So remember, the first one is the object The second one is the arguments, and the third one is the context. If I'm gonna go ahead and do console log context here, and when I'm going to run this create user, fail to fetch, what's happening? Fail to run directory import, Mongo, yes, but where do I do that? Oh, in my user I mistakenly imported that, but I don't need. Now if I execute and check the logs, we see the context, and the context has a lot of things. It has information about the request, like headers, about information about the request, like the body, the headers that was included, the cookies, and at the end it also has our custom field that we provided through the global context that has the hello world. Perfect. That means that through that global context in the server.js, we can provide here the database, right? To do that, we're going to have to import setup database from MongoDB here, from Mongo index. And let's go ahead and do const client equal setup database, and we're gonna call it. And because it's asynchronous, we're gonna have to await. And because it's asynchronous, we're gonna have to make it async. Okay. Now we can provide the client here. Instead of hello, I'm gonna provide the client. Setup database. Setup database will return an object with client. So that means that in our server we're going to have to probably destructure it from there. But sometimes it's not going to be available. So you know what? Setup database. In the setup database, when we catch the error, let's return an empty object like this. So in the server, yes, it's working. Now from our user, from our models users, where we console log context, let's console log context.client. Let's try to execute. And we see that indeed we have access to the client, and we can do the same thing as we did before. We can do client dot or context dot client dot is it database? The database is, how is it called? Sample underscore mflix dot collection with a name movies dot find dot to array. So the same thing that we executed before. Let's see if we can get here the movies. So const movies equal await, all of that. Because we have await here, we need to specify that this resolver is async. And in GraphQL, we can have async resolvers, no problem. Let's go ahead and do console log movies to see what's going to be the response. If I check it here and execute it again, client database is not a function. I think it should be, let me check. In overview, where was the documentation of connecting? Here, connect. Drivers, it should be DB, not database. So it should be client.db. Now, if I'm gonna execute it, Yes, it has information about the movies. So that means that now we can access the database directly from a resolver. But I don't want to always have to do client.db.samples and even like collections. Let's go ahead and in the Mongo index, besides the client, let's also do the DB, which is going to be client.db.movies underscore mflex, right? mflix. And not movies, but sample mflix. And also let's do an array of collections. Maybe it's going to be easier. Like it's going to be, we can do here const db is equal to this one. And now we can automatically send it like this. And collections will be, what collections do we have there? Let's start with users, right? In the collections, users and movies, users and movies. Let's start with two collections. Users is going to db.collection users, and we have a collection movies, which is db.collection movies. So now from our setup database, we are exporting more things. We're exporting the whole client that in some cases we might need to send like some ping commands or so on. We're exporting the database that is connecting specifically with our sample database. And we're also exporting, like to make our life easier, we're exporting some predefined collections. So in our server here, where we have client, let's maybe do Mongo here. And let's expose it as Mongo. And the Mongo is going to have Mongo collections. Should I simplify this to call? Or maybe directly like users and movies, not to have to access like a lot of things. I'm gonna do mongo.users, mongo.movies, and it's gonna be much easier, right? Let's see that in action. So if I'm gonna go to our models user, instead of taking context.client, I can take context.mongo, and after that, instead of database collection, these two rows will be replaced to .movies. Context Mongo movies find, and I can also destructure right away Mongo from here instead of having to work with context. So now movies is mongo.movies.find to array. If everything is working fine, running this query in the terminal should display us a list of movies. Yes, it does. Perfect. So this was the basic configuration of our database. Let me go ahead and do git add, git commit, set up MongoDB, and we're not done yet because we have to properly implement like all our mutations to create users and so on. So let me know if you have any questions so far. How is your day going? Very good. Very excited about this one. How are you? Anyway, let's go ahead and continue, and let's start with some CRUD operation for the for actual users. For CRUD, we have, first of all, we need to get a list of users, right? To do that, in our query, we already have the user. Let's rename it to, I'm gonna leave it user, but the first one is actually going to be a list of users that is going to be users, and in return is going to return an array of user. The array should be required, but the values inside it maybe shouldn't, or maybe we can even make it required like this. So let's go ahead, and before we implement the mutation, let's check the type of our user to make sure that it matches the same type from our MongoDB. If we look in the MongoDB for our sample data, in our users, we see that it has an ID of type object ID. I think in this case it's not going to be an integer, it might be ID, but we're gonna see. Let's make it required. It has a name, Ned Stark, name string. It has email, also string. And it has a password. I'm not gonna worry about the password. So this is our type for the user. Let's go ahead and implement the resolver for our user's query. If I go into the query, we have the first query should be users. Let's start by simply returning an empty array. An empty array is going to be a valid value because it's an array and it doesn't have anything there. I'm gonna go back to our graphical interface. I'm gonna refetch the GraphQL, and I'm gonna start from scratch by defining a query, list users, and this query will call users, and users is going to be an array of users, and here we need to get the ID, name, and email. I don't have any variables yet, so let's remove them from there, and let's execute the query. Perfect, we see an empty array. Now, what we have to do is we have to, when executing this one, we have to query the data from users database. I'm looking if they have like some kind of a documentation here, because I think they did. View project options, no. Anyway, so again, what we need to do here when we request a list of users, we need to execute a find query on the users database. So for that, we need access to the database. We remember that the database is the third argument. So the first one is object, the second one is the arguments, and the third one is our context. From the context, we know that there is the Mongo field that has mongo.users. So what we can do is we can right away go ahead and return mongo.users.find and then do to array. If I return this one, and if I'm gonna go back here to execute it, it's gonna take a bit of time, and then what's gonna say, of course, some error. Because why? Because cannot return null for non-nullable user ID. Yes, I know why. And the thing is that the ID, the ID in Mongo is underscore ID. It's not just ID. So what we have, one option would be to go ahead and in the type definition, instead of ID, have underscore ID. And let's try it like this again. Cannot query field ID because we need underscore ID here. And now it works. But sometimes I don't want my database, or how we name our fields in the database, to influence how we name the fields in our GraphQL API. I prefer having just ID here. So what I can do is I can provide a simple, I will go back to having ID like this. So what I can do is I can provide a simple resolver to this ID, telling GraphQL how should we get ID, knowing the data about a user. So I'm gonna go into the user, I'm gonna say that the ID will be resolved based on the information that we have in the previous resolver. So the object will have that underscore ID. So basically what we're saying is whenever we want to request user ID, take it from the previous one, the underscore ID. This way, if I'm going to refresh, it's going to work. If I'm going to send, we have ID here as a normal string and not underscore ID. This is a very common one, and sometimes you want to make sure that you are either accessing it from object underscore ID, or if it's null, you can access it object.id. So no matter if the previous resolver are using underscore ID or ID, we are still gonna take it from there. And here you can simplify it like this. And you can even do it like ID underscore ID and then return either underscore ID or if that is null ID. Does it make sense or is it confusing? If I execute, come on. Okay, everything is good. So here we have it, a lot of users, maybe even too many users. So let me check MongoDB docs CRUD. The read operation find. I want to limit users find limit. Query documents. So if I will do here find and then dot limit, for example 20, is it going to give me the first 20 users? And it shouldn't be in the create users. Wait a second. This one shouldn't even be here at this moment. It should be in the users here, dot find dot limit 20. Let's see now. If I execute, not sure why it's taking so much time. Yeah, the second time is much faster. Oh, yeah, probably it's because when I do some changes, it reconnects to the Mongo. That's why. But now it's much better. So what we can do is we can continue. We have the list of users. The next query is going to be user by ID. So we have it here, but we need also an argument. We need the ID of type ID, which is required. And only then is going to be able to actually fetch it from Mongo. Let's go ahead here, and we are going to have the object, but from the arguments, now we need the ID to know what is the ID of the argument. And from the context, we need Mongo. So having Mongo, let's go ahead and return Mongo.users. And to find one user, it literally find one. And here we're going to provide the ID that we are trying to search. Let me double check the documentation for MongoDB CRUD, read, find, and where is find one? Where is it? Find one. Actually, I should look at the version 6. Does it have a surge somehow? To be honest, not the best documentation. Quite. NodeJS. MongoDB find one. Okay. So I think there is no find one actually. Okay, so it's not find one, most probably it's find, and here we need to specify the filters that we want to provide. So the value of the field underscore ID from MongoDB should be equal to this ID that we get here. Most probably it's not gonna work because we need to transform it to ID, but let's check it out. So after find, I think we want to do boy, I don't need two array. I need two Mongo cursor to array. Let's see what our method the Mongo cursor next. No, skip size. Pretty map limit hint. Does it have like first? Anyway, I can do maybe dot to array and then at position 0. So let's see now if we send this request. I'm gonna go ahead in here, let's refresh, and I'm gonna remove a query for list of users. I'm gonna copy one of these IDs because I want a specific user where the ID is going to be equal to this one. And back, I'm gonna get the ID and then name. If I search, it's null. Yes, because most probably we have to transform this ID from a normal string to an object ID. To do that, I think we're gonna do a new object ID that we imported from the declaration mark deprecated here. Should it be with capital? And let's import it from object ID. Oh boy. Why is it deprecated? And it's not even working. Let me try to do a console log ID just to make sure that we get the right ID here. We get this string, so I'm gonna try to manually in our database go ahead in the filter, say ID is equal to this string. Will it work? Apply. No, but if I do object ID and then this string, apply, it works. So maybe I shouldn't do a new here, just simply object ID. No, it's a oh boy. Let's see. Didn't work with Mongo in quite a while. Query, insert, not. I need maybe even insert. Query. Let's check the NodeJS item. This is inserting. Specify equality check. Status, okay, but I need to check the ID. The ID. None of them are specifying the ID. Internally, wait a second, collection find one method also performs a read operation to return a single document. Internally, collection method is using find. So find with limit 1. That's good. So I can do find 1. And I don't need to array. Not sure if that's gonna solve because that wasn't our main problem. But anyway, let's see. Okay. It should be new here. Const user equal wait. And here return user. If I do right now it works. Weird. But previously it was not. I simply return this promise. Yes, it works. Okay, perfect. So, but what's the problem with this new object ID? Do you say that it might also work like this? No, it doesn't. But if it's deprecated, what's the solution? Deprecated is use static create from time to set a numeric value from the new object ID. What? Input ID. No. But my input is not a number. My input is a string. So this one shouldn't be deprecated. Because if I do 1, 2, 3, it's not deprecated. But now with ID here, it doesn't know that it's a string. So the thing is that it's a string, so no worries. That's the right way to do it. Okay, perfect. Let's do like this. And yes, we have 2 queries ready to get a list of users and to get one specific user. So if I do now with this ID, we have Ned Stark. Perfect. What would be the next step? The next step is going to be to create a user. And to create a user, we need a new user input. And in the new user input, we will not have age, but we will have email, for example, with a string like this. So let's go ahead in the create user mutation. What we need to do is we need to insert this to the database. So we're going to have to call insert. Let's look at the documentation. Again, getting lost here. CRUD operation, insert document, insert one. So insert one document, and what will be the response? Behavior. If a field, okay. The ID will be automatically created. This is an example to insert one. The operation returns the following document, acknowledge and inserted ID. So the response right now, yeah, let's do it like this. Let's do const response is equal to await mongo dot users dot insert one, and here we will specify the user input, because the user input has the field that we want to insert, the name and the email. The ID doesn't have it, but if we don't specify it, it's going to automatically be generated for us. Let's go ahead and do a console.log response here to see what's going to be the response. Now let's go to our Ruru. Let's refresh and let's define a mutation. New user. The new user will have a variable called user of type new user input, which will call the mutation create user that has a field user where we will send the variable user. Back we want ID, maybe name, maybe email. Now in the variables, we need to provide here the user with name, Vadim, come on, Vadim, and the email like this. So what's going on? The new user input is required, yes. Let's try to execute this query. Create user, it did something, not really sure what it did, because it was supposed to give me back 1. But anyway, we have this F1, and here it's F1. What's happening here? Create user. I'm not expecting to see this one here. But if I go to the Mongo Atlas And if I'm gonna look for an object in the users with this ID apply, I see that it was introduced. But why is it returned correctly here? Can you explain? Because I don't understand. What? Create user. Create user. Create user. I might understand where everything else is being taken from, but how does the ID? Because ID, I specify here that it's ID. That's very weird and not expected. Let's console log it 2 times at the top and after the Mongo insert. If I send it, now it's unexpected. That's correct. So yeah, this is the user that is coming from the input. Duplicate key error collection. Oh, it has the same email. So if I do vadim123, send. Oh boy, why does it work? Because as you can see, that's again very weird. The user that we are sending here to Mongo, I'm console logging it at the top, I'm console logging it at the bottom. This user is being changed. At the top, it only has name and email. At the bottom, it has name, email, and ID. Okay, not sure if that's a bug or a feature, but usually how you would do is you would take basically the response. The response has the inserted ID, and you will say that, hey, ID is going to be equal to response dot inserted ID. And then the rest of the user. But anyway, that's good. It works. We can create users. We can insert them in our database. 1, 2, boom, it's there. And it has an ID. If I check, if I create a new query here for query get user, and I get here user with ID, the one that we just created, and then take name and email, execute it, we see that it was exactly the one that we previously created in this query. So, okay, that's good. That means that we have 2 queries, list of users, get user, and create user mutation, all working perfectly. The next one would be, the easiest would be delete user. So delete user is going to first receive the ID of type ID, and it will return a boolean, true or false. Now let's go ahead and implement the delete user mutation. After create user, where we have it here, delete user is going to be an async function. That is going to do the following. Is going to await Mongo, but we need the Mongo, so I'm gonna do underscore, or let's do obj args, and from the context I'm gonna take the Mongo. And so let's do mongo.users.delete delete one. Does it have a delete one? Let's check. Let's check the documentation for CRUD operation, delete documents, insert many, delete. I don't want delete wall, only one document that matches a condition. delete one. Yes, delete one. Make sure you call delete one, because if you call delete without any filters, it's going to delete all users from the database. If you call delete one, even if you don't provide any filters, it's going to delete maximum one and the first one that matches. The one that we want to delete is going to have an ID that matches the object ID that we take from the arguments. So in the arguments, we're going to have an ID. Let's pass it here. So this is going to be like this, and let's return true. But does this delete user return anything? Index atomic could delete many, delete one. What does it give back? Promise, callback, returns promise if no callback passed. Anyway, it's going to return something, but we're going to consider that it was deleted. So let's go ahead in our this one. When we query get user with this ID, everything is going to be okay. Let's go ahead and add a new tab here. And I'm going to copy the mutation from new user. Only this time is going to be called delete user. I'm not going to have any variables here, but I'm going to call delete. Let's refresh to get delete user, and here we need to provide the ID. And delete user doesn't return an object, it returns one value. That's why I'm going to remove it from there. And let's provide the ID of this one, this user, with D8 at the end. So D8, if I execute delete true, if I go back to get user and search it again, we see that it disappeared. And I really hope that our users are still there. So if I'm going to do here, instead of user, users, ID name, I hope that they will still be there. Yes, the rest are still there. So if you don't really like Geoffrey Baratheon, you can take his ID, you can go to delete user, can provide it here, execute it, then come back, run again the query, and there is no... I already forgot how is his name. Geoffrey. Yes, it was deleted. So that easy. We have also the delete operation. Now the last one for our CRUD operation, for our CRUD operations, is the update. An update user will be a mix of create and get, because we need to know the ID of the user that we want to update. So that's going to be the ID. But we also need to know the new user input. So new data or new user. This new user, you can either have a separate input field if you don't want to allow overriding some fields. For example, if we don't want to be able to override email, we can copy this one as a update user input and delete the email to allow the user only to update his name. That's also possible, but you can reuse different inputs as well. So let's not say new user, but update. Let's just say update. So the update user will have two arguments, ID and update. Let's go ahead in our mutation and create update user. That is going to be an async function. The object we do not need, so we can call it obj, but in the arguments we're going to have both ID and also the update. From the context, we of course need the Mongo. And what we will need to do is we will need to do mongo.users.update1. Let's check the documentation of update 1. In there, we're CRUD operation, update document, update 1. The first one is a filter, the second one is update. Okay. So insert update one. The first one, yeah, is the filter. The first parameter is the filter. How do we want to find the object that we want to update? We are going to find it by ID, by creating a new object ID from the parameter that we receive from the argument. And the second option is the update. So there I'm going to provide the update like this. And back we are going to receive what? Updating multiple. And in this case, we are actually we're replacing the document altogether. What's going to be the return? Come on. Let's just see const response equal to this one, and let's console log response. And in the update user, what do we say here that the return will be? Update user. We didn't specify what's going to be the return. The return should be user. So let's go ahead here in our rule. Let's get a user, for example. Let's create a new user, for example, Vadim, like this. Doesn't want Vadim 1, 2, 3, 4, 5. Yes, now we have his ID. We can go ahead and search for him here. If we check Vadim with the name Vadim. Let's now go ahead and define a mutation called update user, where we will call the update user method, and back we're gonna get the ID, the name, and the email. The update user needs the ID of a user, which is this one, and it needs the update, which will contain the updated name. For example, Vadim 1, 2, 3. Now if I execute, something is not working. Yeah, because I didn't provide here any variables. I'm hard coding them here. And yes, I'm not returning anything. But what I get here in the console is update document requires atomic operators. Duplicate key. No, wait a second. Requires atomic operators. Invalid argument. What is the update there? Console log update. But I don't want to replace actually, because I want to keep the email there. So I think I'm gonna have to simply do a set. In the update here, we see that we need to update operator. So it should be set. For example, instead of update, I'm gonna have here set like this. Yes. And what do we want to set? We want to set field value. So the field is name, the value is update.name. Now, if I execute this one again, it's null, but in the console, we see that the modification is 1. Okay, modification 1. Update 1. And I can return back. I'm not sure. I think in the update 1, I can also specify that give me back the updated object, but I can simply do a query, which wouldn't be very optimal, but still it's gonna work. So Mongo users dot find one. Let's find one where ID is our object ID. So now in this situation, not const but return. This Mongo, if I do, is going to first update it, then it's going to return. So if I update this one to back to Vadim, it's going to update it, fetch it again, and return it here like this. And now it's updated in the database as well. Perfect, perfect, perfect. So that means that we have all the CRUD operation, guys, for our user model. Okay, that was a lot. If you want to continue, I highly encourage you to do the same for the rest of our models, like movies, comments, and so on. I'm gonna go ahead and do a git add, git commit, users CRUD, users Mongo, perfect. I only want to show one more thing. I want to show how we can create relationships between things. For example, in our Mongo database, we have comments, and a comment has email, right? Why is it email and not user ID? Users, sessions, user ID, movies, cast. But anyway, comments have email. So they only know the email of a person who commented this. But how can we connect them together in order when querying the comments to know also the name of a user? To do that, let's first of all create a query for the comments. So what I'm gonna do is in the GraphQL, let's create a new folder, comments here. And in the comments, let's create, or no, in the models, wait, I'm already tired, but let's do it together. So in the models, let's create a file here, comments.js. From the comments, we need to export two things similar to how we do here. We need to export the type def. From the comments, export type def. And also we need to export the resolvers. Now in our index, we need to import them in the similar way as we imported them from user. We need to import them from comments. So the type def as comment and resolvers as comment resolvers. Comment resolvers. Comment and comment resolvers. Now we need to give them here in our schema. After the user, we're going to have comment, and after resolvers, we're going to have comment resolvers. Now let's go ahead in type definition. I want to define a type, the type of our comment that has what? ID. Let's actually do underscore ID. It has text of type string, and it has email. Let me check if it's actually connected, because if I go ahead and check a user with this email, will it find it? Yes, it finds it. So email string. Now I also want a query type, query called comments. Comments. It will give us back an array of comments. In the resolvers, we need to define the resolver for our query called comments. And this resolver will, they have object, arguments, and the context where we can get the Mongo. From Mongo, we need to define a new collection. So let's open Mongo index here. And the same way as we have users, movies, let's define here comments, db.collection, comments. Now from the Mongo here, we can return mongo.comments.find. We're gonna find a lot, but we're gonna only limit, let's say, the first 20. And let's do 2 array. Now let's go ahead and see if it actually works. I'm gonna refresh this one, and let's create a new file here, query comments. Let's do comments, ID, text, and email. If I do that, we see 20 comments from users. But we know that logically, like in a graph, a comment is posted by a user. In our user interface, we might display users with their avatar. We might display comments with user information with their avatars and so on. So what we actually want is we want to be able to query here the user with his name and password, or name and avatar and so on. We haven't defined that a comment can have a user property. Let's go ahead and try to define that right now. To do that, on the comment type, we will say that besides all the fields here, you're also going to have another type called user of type user. Now, if I refresh this one, I can go ahead and do user. Not sure if it's going to refetch, because it might not know the user here. But no, it actually works. So we can query the user with his name, but at the moment the user is null because we didn't provide the resolver. We didn't tell GraphQL how, knowing the information about a comment, how should I grab the user? Well, logically is you have his email in your data, go ahead and query it from the database and take all the information about the user from the database. To do that, we have to provide the resolver for the type comment of a field user. Let's go ahead and after the query, define here the comment type. And the comment type has the user field that needs a custom resolver. The first parameter is the object. The second one is the arguments, and then we have a context with Mongo. This is where the object is actually helpful, because remember, as I was saying, like to get the user, we need to look at the parent object and take the email from there. The parent object is actually our OBJ here. So we can take from here email, and it's going to extract the email from the parent object. Now what we can do is we can have a look at how we queried in the user for getting a specific user. In the queries of a user, we did this one. So we can do the same here in the comments. Return Mongo users find one ID with this object ID, where I'm going to import it from there. But actually, it's not finding one by ID, but it's finding one by email. So I don't even need the object. Okay, that's all we had to do. We have to specify, knowing a comment, how should I get the user? And to get the user, we're going to query the database and find the user with that email. If now I'm going to do it like this, we're going to see that now all the comments, they have also user information. Here, John Bishop, name, and so on. And the cool thing is that you can have access to anything here, like his ID, his email, and if he has relationships, for example, if he has, like, I don't know, friends, you can do a lot of nested queries like this all the way. So this is actually the power of GraphQL, and that's why now anytime we specify that something will return a comment, we will always be able to get the other relationships for that comment, because we define it one on the comment type, and later it can be used anywhere. For example, a post can have comments, and the comments can have users, so everything is interconnected. So that was our relationship between this one. So let's do git add, git commit, comments, connection with user. Perfect. And you can do the same connection, try to do it yourself on the user, to have give me all the comments that this user has posted. Actually, let me try to do it. Maybe we're not gonna have time to deploy this API, but the backward connection is going to be important. So on the type user, I want to say that, hey, I want sometimes to be able to query the comments that that user provided. So it's going to be an array of comment. Now we need to specify how should we get the comments knowing a user. For that, we're going to go into the resolvers of a user. Let's provide the resolver for the comments. We're going to get the object, we're going to get arguments, and we're going to get the context with Mongo. And what we should do is I'm going to find let's take this one, for example. And in the comments, I'm going to do not users, but mongo.comments. I want to find comments where email is equal to the email of this user. The email of a user, we can take it from the object, because this is the parent of a comment is a user. So it has an email, we're going to take it, we're going to filter, find only those, and we're going to limit to 20. Now, if I go here, we can go ahead and say, give me, for example, get user with name and email. And for this user, I want to see all the comments that he has created. So it's going to be text and also email, just for us to confirm that it's the same. So if I run this, I see that there are no comments. Why? Because comments, is it like this? Comments, find email, console, log, email. Oh, yeah, wait a second, because there are no comments with my email. I'm no one. But if I'm gonna take the email John Bishop, not the email, the user ID of John Bishop, And if I'm gonna go here and say, give me the user with this ID and all his comments, we're gonna be able to see information about him and comments that are only related to his email. Usually you don't need the email here. So yes, that's how you can create relationships. And you can have circular dependencies. For example, for a user, we took the comments, and a comment can take information about the user. So you can do that again. And this will give the user name, email, comment, and for every comment is gonna also have his username and email. In this case, it doesn't make sense because it's circular, but I wanted to show you that you can go very deep into your fields that you're querying here. And that, my friends, is our git commit -m user comments connection. Yeah, that, my friends, is our GraphQL API. To be honest, we took a little bit more time than I expected to explain everything, because we also covered all the CRUD operations for our users, also showed the relationships and so on. So there is not really enough time for us to deploy this server. My plan to deploy this one was to deploy it to AWS EC2, which is a cloud compute service. And instead of that, let me actually try to show you in what tutorial we have done that, because we have worked with let's do live streams. Let me remember in which tutorial we deployed something on AWS EC2. It was this one. So if you scroll down until you see deploying Twitter backend on AWS EC2 and AWS RDS, the process of deploying the Twitter backend to EC2 is going to be exactly the same that you need to deploy the current server, because our GraphQL server is nothing more than a simple Node.js that can be started with running Node. On the server, you're of course not going to watch, you're going to simply run node server.js. And of course on the server you most probably you're not going to use Node directly, but a tool to run it permanently called PM2. And PM2 is a process manager for Node.js, which is used in production to make sure that your application doesn't stop working after something crashes. So PM2 is going to inspect it, is going to analyze, is going to restart, is going to monitor it. So by simply installing it on your virtual server and then running PM2 start application, is going to be, let's say, production ready and monitor this. So yeah, check out that tutorial because it's exactly the same. And if you have any questions about today's tutorial, about GraphQL and so on, let me know. Sandy is asking, when will you make a complete serverless application with Node.js and Lambda, as EC2 is outdated? Guys, I'm not sure. Let's see how many of you are interested in more of the backend tutorials. If you are interested, let me know and I can do more of this in the future, because on this channel we focus a lot on mobile applications, and I know that that's what you guys enjoy. But me personally, I love working on the backend. I was actually more of a backend developer when I was working at Amazon and so on. So would really love to prepare more tutorials for backend, especially around serverless application using Lambda functions. That would be something exciting for me to cover. Havadim, can you do a project on voice call? Yes, we can. Try ID to string. Doesn't he know that he is live? What happened? He's not looking at the chat. Sorry, guys. I was so focused on that one. MongoDB auto-generated ID for every collection created. Why are not using Mongoose? Because I try to keep it very simple. NestJS, one love. All right, guys. Thank you very much for joining. I hope you found this valuable. If you did, make sure to subscribe to the channel. We're very close to hitting 100K subscribers, and that would mean a lot to us. And yeah, we have prepared a lot of new tutorials coming next following weeks. So make sure to also turn on the notification bell so YouTube notifies you when we go live. That was it for today. I will see you next week.